Okay, it's like our last official lecture. But first, we'll just take attendance, and then I'll get into all the nitty gritty about that. So here's the QR code. And if you guys, oh wait, sorry. Yeah, the number of the day is 404 after HTTP response errors. It's not that many Android related numbers, so gosh, sorry. Okay, actually, I'll just hold it. Okay. All right, so now just for some announcements. Expect the Hack Challenge announcement to be coming out soon. The Hack Challenge kickoff will be next week. I think during the regular lecture time. I'm going to double check. They haven't actually released like the timing wise, but I know it's for sure going to be next Monday. Usually it's around this time. It might be like 7:30, either like starting like it's just within this time block. So there might not be lecture next Monday. Stay tuned for that. Everyone is required to come as this is where a bulk of the information about the Hack Challenge is given. The bonus lectures will start the, next we'll be going over kind of what's left in the course. So today is actually like the last official, I guess, like Android lecture. So yeah, the bonus lectures will start the following week with Firebase, and then it'll kind of give a roadmap of kind of what you can do after learning some of the basic concepts in this class. And the following class will just be like an open office hour for the Hack Challenge. And a little bit about the Hack Challenge. So you'll be paired with some mentors on the Android sub team, particularly the TAs. So feel free to ask them any questions about like implementation or feasibility of your project, and they'll guide you through. They're pretty knowledgeable because I know a lot of them myself, so I can speak and attest to their capabilities. Um, yeah, and the next and last homework will feature a real backend, so you can kind of get used to that in hindsight of the Hack Challenge. That should be pretty fun. And on the next homework, there's no cap on the slip days since there's nothing left after this. Previously, it was 2 per assignment, but you can use the rest if you need it. So if you have 4 left, you can use 4 on this assignment or 6, which is, I think, the max allotted. So yeah. And yes, there will be an end of course feedback form due with, I think, yeah, with homework 6. It might be later than that, we'll see, since it's not actually like the end of course yet. It's just like the end of the official lectures, but yeah, stay tuned for that. Sorry. Any logistic questions before we dive into lecture, I guess? About Hack Challenge or anything else of what's to come? Okay, cool. So now we'll just be going over a quick review of what we did last time. So last class, we went over fragments. Last week we went over fragments. So just to review, fragments allow us to reuse our code, reducing redundancy and making them more modular. And fragments have their own lifecycle that's tied to their host activity. And we showcase a little bit of the fragment manager, which lets you do different operations on fragments themselves, like replacing or adding or removing. And we also featured a little bit of navigation last lecture too. So we saw a little bit with view paging, and then we also saw the tab layout navigation. And we went over briefly a little bit of networking, but we'll dive more into that this lecture as well. So our first topic of this class will be about data. And the first thing that we're going to cover in terms of data is something you've already seen. Like I said, I haven't actually put a name to what it actually is, but it's called bundles. Where you've seen bundles, for example, is when you use like put extra on an intent, and when you're specifying any additional information to that intent inside, you're using a bundle to specify the data that you're putting inside of that. So when you're using like a resulting, when you're in your resulting activity, if you're doing like things like get extras, the type of what that call is a bundle. And then you're using the keys associated with that to get the various data stored. So yeah, it's just a mapping of strings to various values, and we use it to pass information along from activity to activity or fragment to fragment. Um, so bundles are limiting in the sense that they can only be used to transfer data between parts of your app, like activity to activity or fragment to fragment. So if you want to propagate data from, say, fragment A all the way to fragment D, or activity A all the way to fragment D, you have to propagate the information along from activity to fragment, which can be kind of tedious. So what if you want our data to be globalized such that all parts of our app can see it without having to go through this annoying transfer process of propagating the data along these streams? In comes singletons. So I kind of gave a preview of this, I think, during the last discussion, where I used singletons as a means to transfer data between our fragments, because I wanted to keep the data globalized and then use that as a means to kind of help with that. So a singleton, I guess defining it more formally, is a design pattern that restricts the instantiation of a class to only one instance. So you kind of have this single point of truth that everything can access. A singleton class is a class that is defined in such a way such that only one instance of the class is created and can be used everywhere. So it's a global reference that everything can access to. So if you see the graphic on the right, you have these two different clients, and they're all accessing this single instance where they can pull data from. This design pattern follows a kind of a specific contract. So the first rule is that you have to have a private constructor, and this private constructor helps to prevent the class from being instantiated more than once. If you only ever want one instance, we want to be able to control kind of how we're creating the class in the first place, or the object in the first place. The next rule is that it has to be globally accessible, because a singleton is meant to be a hub that all can access. So it's important that the reference is globally accessible, or else what's the point of having it? What's the point of having a singleton? You know. And then this third point is consistency across multiple threads. The third condition is something I don't want to get too bogged down in the details of, especially since most of you are probably freshmen and sophomores and you haven't really taken an operating systems class. We'll kind of give a small introduction to kind of threads briefly, a version of threads later in the lecture, but it's not really what true threads are. And you can kind of, I guess, see the relation with how it comes to play with singletons. So yeah, Kotlin makes it very easy for us to have singletons and automatically fulfill this contract. So we don't really have to worry about like the details of making sure that we follow all three of these things. It will automatically do it for us. And we can do that, which I did last class as well, with this object keyword here. So here's an example of singleton I defined that just keeps a simple centralized counter. So what's special about this piece of code, as opposed to, I guess, things you've already seen in this class, is the use of the object keyword right before the name of our singleton. So at the very top of the singleton it's defined as object counter. So in Kotlin, object is a special class that only has one instance, which is good, but already fulfilling part of our contract. So if you create a class with this object keyword instead of class, as you've seen previously, the Kotlin compiler will make the constructor private, which is what we need, create a static reference for the object so people can globalize it, and initialize the reference in a static block, which is part of the third point. So by using this keyword, we're automatically fulfilling all parts of the singleton contract in one go. So it's pretty nice. I guess to cover parts of kind of what the singleton is, I just defined this single variable counter, and then you can have, I just wanted to show because you can have like an optional initializer block in the middle here if I wanted to, I could have defined counter to be zero directly. I want to showcase kind of what you can do with this init block if you need it. And this function here just increases the counter and returns the old value. So you can also define whatever you want in this, I guess, example singleton. So pretty neat. So that's it for data. And the next part we'll cover is storage, particularly persistent storage. So Andrew offers a lot of ways to tackle persistent storage. And what I mean by persistent is that it'll last across your app sessions. So if you close your app and open it back again, you'll still have that same information available to you if you need it. Today we'll tackle a simple way of doing that through, it's called shared preferences. Right. So shared preferences offers a framework to save persistent data in key value pairs, very similarly to the bundles that you already worked with. It works for any primitive data type, meaning booleans, ints, longs, floats, and strings. So how can we use this to our advantage? So shared preferences makes it incredibly easy for developers to store, I guess, information when it comes to like a user, maybe like user state, user settings, or their favorites, or keep track of small bits of important information, like maybe like login information if you want to have that stored in your device to keep that process fast for them. You can store that. You can use share preferences for that as well. Um, and as opposed to this, you would have to, if you didn't want to use share preferences, you could access storing things directly on a device. But that requires a storage permission, which can kind of be tedious and isn't always guaranteed because what if the user denies the permission, then you're stuck with not being able to store information. So because it's classified as a dangerous permission. So share preferences, you don't require any permissions. It's very easy to just store values and retrieve them back if you need to. Um, a downside to share preferences, which is kind of sucks, is that the preferences are deleted if a user decides to delete your app or clear the data of your app. So a more permanent solution like coordination with the backend may be necessary if your data needs to last, which is probably what you should be doing anyways. If you need to store information that long, you should use a backend. But this is quick. This is a method for quick and easy data that you need to store. And a positive encounter to that is that the data is very easy. I mean, shared preferences is very easy to implement. So you can check out the course textbook if you're interested in seeing that. It's very simple. Which it may come in handy if you need it for the hack challenge. So I wanted to share it with you guys. Right. So the last part of lecture is we're going back to networking. This time we're going to get more in depth about networking and Android particularly. Last class we just introduced the basic concepts, but we're going to get more in depth into what it is. So to enter networking, most interesting apps use the internet to receive and store data. Our application needs to know where to get the data and how to use it. These are just some important terms to know. You have your client, your server, and your API. So your client is usually like your mobile application. It's what's making queries to some URL or backend or service. The server is a computer which listens to the requests on said URL or said service, responds to the query as appropriate by looking through its database, editing things, etc. We don't really worry about that since we're front-end people, so we don't care about what happens on the server. We just care that it does the right thing and it does its job. Yeah, and then the API kind of ties these two things together, like it kind of defines the relationship between the client and the server. It'll specify functions. So for example, if I give it some input, it should give me back some output, for example. So as a front-end developer, we're focused on the API, as that's the contract that specifies kind of what we should expect from our server, input, output wise. So usually what's responded back by the server is some chunk of data. And that chunk of data is usually represented as what is called a JSON, which we'll also talk about later too. This is just a diagram of kind of like what I mean by API. So the API defines how software apps communicate. So for example, the client here says to the server, I want to look for restaurants in New York that serve avocado toast. And the server then gives right back to us a list of businesses that does just that. So I mentioned JSON earlier as a means. I guess any questions before about like client server and API before I continue? Okay, cool. So yeah, briefly, I mentioned JSON as like a means that servers return information back to us. I kind of want to intro that more of what that is now, because you'll see it a lot in terms of in networking. So JSON or JavaScript object notation is a minimal readable format for structuring data. It is used primarily to transmit data between a server and some client from whatever request that we've given it. The two primary parts that make up a JSON are the keys and the values, and together they make up a key value pair, where the key is followed by a colon, followed by the value. The keys in question must be strings, but the values can be anything that's valid under JSON data types, which includes, I think, strings, numbers, arrays, booleans, null, and other JSON objects. So on the right here, we have this is an example JSON object literal. Here it is more zoomed up. So here we have just like a single key here, which is employees. And the value is an array of objects. And the objects in question in JSON is just like the collection of key value pairs. And the key value pairs are just separated, as I said before, with colons. And the JSON object literals are surrounded by like these curly braces. So everything inside of the curly braces is a part of the object. So of course, in this example, we have objects within a single JSON object. This outside curly bracket here. Yeah, there you go, outside curly bracket. So JSON structures, that means that JSON structures are nested in that sense. We can have JSONs within JSONs, et cetera, which allows us to represent kind of a large and complex types of data. There are lots of libraries available in Android that can kind of make navigating through JSONs more Android friendly. For these are just strings. We don't really know how to like work with that in terms of how can we use that in, I guess, our Android code. And there's lots of libraries that kind of help us parse do that. Today we'll introduce you to, I think it's Moshi. Yeah. Any questions about JSON? Right. So this is just like covering like the third-party APIs. As I stated earlier, you'll usually find, most commonly you'll find JSONs as like the output to your APIs. And your APIs serve as like a contract. They specify what you can expect given some requests. And your hack challenge, you'll also see your an API example from your backend. Your backend member should be giving you an API, and you should be using that as a means to kind of set up your networking on your app, because you should expect those endpoints to be valid in terms of when you're creating your app. So that's the contract that they have to abide by in terms of client and server relationship. And on Wednesday, we'll introduce you to an easy way where you can kind of debug networking calls through an application called Postman. So stay tuned for that. Right. And this last part of networking is called coroutines. So if you were to run a networking request on its own, say in the onCreate of your main activity, there can be many things that can go wrong. Perhaps the networking request takes a long time to complete, which I usually do. And in that case, the user is left waiting. And the app will freeze to reflect this as it has to wait for the request to be finished. And since you're doing it on the onCreate of your main activity, and things are done sequentially from top to bottom. So yeah, and the other thing is maybe your network request can fail, but the application has no way to detect and handle this failure. So how can we go about fixing this? And we can do that by employing coroutines. So a coroutine is an instance of suspendable computation. So that's kind of confusing. So what does that mean exactly? Right, so here's just a diagram. So there's a difference between blocking versus suspending. As I mentioned earlier, proteins are suspendable computations. So in blocking, right, function A has to be completed before function B, and then the program is locked for function A to complete its execution. This is kind of like the common way in how functions are executed and how you're probably been taught all your programming career that things are ordered, done sequentially from left to right, up and down from function to function until they're done, and the next one takes over, and the next one takes over. This is kind of true in Android as well, where you kind of have a single point of access, and things are just, especially in your on create, it's a single point of access, and things are just executing from top to bottom in that function. Um, and then in suspending, you kind of see how in function A, there's kind of like this like break, this gap where function B takes over. So in suspending, function A initially starts and can stop, and then can let function B execute, only to then resume later after function B is done. Um, so yeah, so the best way to kind of learn about coroutines is through an example, which I'll showcase next. Right. Okay, so this is kind of our example coroutine. So here I have an example. This kind of showcases like the difference at runtime and coroutines and how suspension works and how it's handled in the order of execution. So I'm gonna try to break down like the different parts of kind of this code here in terms of how we get this output here on the right. I don't know if you can see that here. The output here that's done here. Um, so this first thing here is run blocking, like the function, the line that's right after this equal sign. The run blocking is a coroutine builder that bridges like the non-coroutine world of your regular Android code to the code with coroutines inside of this like curly break, inside of the scope here of run blocking. So in the case when you're using run blocking, um, it blocks in this sense where function A is done until completion of function B. It blocks until all of its children are done running. So you have to be careful when you're using run blocking because it'll wait until all of these things are done running. The next thing we have is launch, which is just another coroutine builder. So it just launches a new coroutine concurrently with the rest of the code, which continues to work independently. And then inside of this like first launch here, we have this delay function. And delay here suspends the function for a brief moment of time and gives other coroutines a time to run. And inside is given like it's given like a millisecond value. So in this case, the first one is 200 milliseconds. So when we're delaying here, we're literally doing this diagram on the right here. We're suspending the function and letting some other function kind of have its course in terms of execution. And then this last point here is coroutine scope. So it's similar. Coroutine scope is similar to run blocking, in that it'll wait for its children to finish before completing. However, the difference is that instead of blocking and waiting, it'll just suspend itself, thus allowing other functions to execute. So kind of in this like flow here, in the example above, we see that run blocking forces the app to block this whole function main until all of its operations are complete. And then we see that the code in coroutine scope C starts to run before suspending and allowing the code in like this first launch, the scope B to complete, and then returning to the nested scope within C to then print out like this code that's in the delay here in the number 3. And then finally we print out number 4. And that's all because of the way that we're suspending things. So first we suspend the first thing for 200 milliseconds. And then in the coroutine scope, we're suspending for 500. But then the 1 finishes first, so that's only suspended for 100. So then we get that that's printed first. And then we get number 2 printed next, and then 3, and then 4 after the coroutine scope is done. So kind of how does this relate to networking? I kind of hid a fact in this previous example here that I'm going to kind of disclose now. So all call and coroutines must run on dispatchers, and that kind of delineates kind of how the work is split up. So call and coroutines use dispatchers to kind of determine where coroutines are executed. So to run code outside the main program, you can tell call and coroutines to perform work on some dispatcher. So in the case of when you're making networking calls, you can use the IO dispatcher to execute networking code on that dispatcher. Or if you're doing anything that's like computationally intensive, you can use the default um, dispatcher to do that as well. And the main dispatcher is just used, that's like the default. It'll just, well, it's kind of, the name kind of doesn't match up with default here in the main there. But the main is used to kind of update your UI. So it's kind of what you're doing when you're running on Create anyways. You're updating your UI, you're running some functions. So that's the example of what you can use the main dispatcher for. So these are like the three types in terms of like what computational jobs that they like to handle. Um, so yeah, generally networking calls are called in the IO dispatcher to prevent consuming all of the resources on the main app execution, which, as I mentioned earlier, will kind of freeze up your app to the dissatisfaction of the user. This is not what we want. Here's an example of kind of using like the dispatchers that I mentioned earlier to kind of abstract away from abstract away and use our networking calls in like another scope, in another realm. So here you're using like this dispatcher's IO to execute our networking call, and then we're using the result to then update some UI in this function A up here. Any questions? Okay. And now we're just going to move on to our demo. We kind of see a lot of these things more concretely than just explaining theoretically. So yeah.
So for today's demo, we're actually gonna navigate a little bit of the homework. Like we're gonna set you guys up so you guys will be ready and know what to, where to start for the homework. So I'm not sure if you guys have, ah, my screen. So I'm not sure if you guys have looked at homework 6, but homework 6 is basically trying to have you to make a note app that you can edit something locally, save the history of your edits, and also send your notes to the cloud API that we have provided for you, and also be able to retrieve data from the cloud. So the API we provided for you is like this. Whenever you got the API, starting off by reading the specs, knowing that what functions it provides for you. So it has a bunch of get and post requests. Um, so for the demo today, we will be going over one of the get, and um, the other is for to go over how to make a post request in your front end. So if you guys want to follow along, feel free to um, download the starter code from the website, Gitbook website. So the starter code will look like something like this. When you open it up, and it has a added node. It has a main activity, added nodes activity, a local node activity, and things like this. What is worth looking at is first of all the Gradle. In order for you to do a lot of things on networking, you will be using Moshi, so you have to include this too in your dependency. And also OKHTTP is a client library, and these two libraries are for handling the threading. So yes, just check every time if you like for a hack challenge, remember to have all of those libraries installed in your dependency. Another thing um, that you need to look at is inside your manifest, you need to include use clear text traffic um, for like under the application tab. You have to set it up to 2. So basically a lot of requests that you usually like when you're browsing online or you're using other app, you might be using HTTPS rather than HTTP, which is more secure. So this is just allowing you to use like barely just HTTP to handling those requests. Yeah, this is just a line that I need to have. And last but not least, include use permission so that users will allow you to access their internet or yeah, so that they have internet, because otherwise you won't be able to access any of the API like cloud storage. Okay, with that all set up, let's go to um the main activity. It's a lot on my. So what we actually want to do for the app is that, let me just open this up. So like you can enter some things in this edit text. This is the main activity. And you can say save the changes in the cloud. And what we hope to happen is whatever you entered, it's saved and then it's sent out to the cloud. And when you open up the app again, you probably don't see, but there's actually a recycle view beneath the save change in the cloud place. So when you reopen the app, we want you to be able to retrieve the data from the cloud, and then it will show up inside the recycler view. And you will be able to click into each of the items of the recycler view to further edit the nodes you saved on the cloud locally, and then you can send the data up to the cloud again. It's kind of like a cycle. And we also would like to that crash because I haven't like implemented everything, but we also want you to create something called repository. It's kind of like a history tab that you will be using either singleton class or share preferences. We'll be suggesting to use singleton class is much easier, and I'm also going to make a demo about it. So the singleton class will require you to save the nodes, like your local changes of the nodes, onto it. So we're gonna start off um, by implementing a function called populate node list. It's a function that get called last when you first like the whole main activity gets started off and like created. So we basically like retrieve cloud data and then get all the lists. This will be So we'll be using this um we'll be using this commands to get all the posts. So to start it off, I'm gonna create a request get. So the syntax of it is just request builder URL. So the URL requires a base URL, and also the rest of it will look like this, provided like in the API. So we already provided the base URL for you. It's over here. It'll just be base URL. Okay, so this is a very simple GET request that was supposed to return all of the previous uploaded notes for you. So after we create a request, we wanted to like get some response from it. What you need to do is, so client is the OKHTTP client that like is kind of just a library. So we want to get some response from the client. We first call client with this request that we just created. And then inquiry is kind of like it's a method that returns like a response callback. Okay, so this is asking me to implement the methods required by this interface. There's two things to implement. One is on failure. Usually it happens if you are like switching the Wi-Fi or there's something wrong with your internet while the request is being made. So it basically, like before any response even coming back from the client, it just failed. So usually it's not nice that it happened. What we need to do in this case, I would just be like printing the error, I guess. So in the better case, we get a response. Um, but that response can also be saying, oh, this is not successful or it is successful. So if the request is not successful, um, actually we can use the syntax response use. So in this case, I'm just like abbreviated. So it in this case will just be the response. You don't have to use it. It's just a syntax that may make your code looks a little nicer. So if it's not successful, you can throw arrow, you can log it. You can log the response. Else, we will like else it is successful, so we will be getting a list of nodes from the API. So this so that our return value will be a JSON string. It will be in JSON format, like very complicated. We want to make it to something that we can use for our front end app. So this is where Mochi come to play. So we're gonna go to a data class that we have created ahead of time. So how we created this data class is actually we created based on the API requirements. So in this API, it says every post has this following format. It has a title, it has a body, it has a poster, like whoever is sending it. You can also add something else, but you have to have the three exactly the way it is to make a request to make a request valid, basically. So I created this data class with the body, with the poster. I also created ID. You don't have to have it, but I'm creating it just in case if there's one sender that send multiple texts, I might need to give it like different ID to know which one to delete in the future if I need to delete a specific one from a specific user. All of those are familiar because we have been creating data class before. The only thing you need to remember is this name, like this. What? Oh, scroll up. Yeah. Right, okay. You all need to do is to make sure the names and like all of the names and that's like the type, the value type have to match. And after that, you create a data class. You need to add this tag. This tag this tag is from Moshi that will basically generate adapter for you that will convert the JSON into like colon object, colon data class you can use. So that's all it is doing. All you need to do is create this data class according to this format and add this tag. So add JSON class generate adapter equals to true. Okay. So going back to the main activity. On line 37, I have done something over here that basically create this adapter. Like in the tag, in the node tag, it's just saying that, oh, I wanted to be able to, like it's checking it's a flag, I want to be able to create a adapter with this data class. But back in the main activity, actually, I did Moshi adapter with this node class, and I did create an adapter for it. So this adapter comes handy when you actually have a return value from your API from your backend. So the return value of this GET request will be like a list of nodes. So I'm just creating a variable of node list. And then I'm calling the adapter. I'm converting the request, like the response from JSON to the data class. Okay. So now in this case, I will have a node list of, it will be like a list of nodes that contains um of the nodes that the cloud holds. So I'm gonna run through all of the nodes, and then I'm gonna add it to my global nodes I created. So my global nodes is just a mutable list of nodes. And then I'm gonna add it in. Last but not least, as I talked about in the main activity, in the bottom of the main activity, there's a recycle view. We need to populate that recycle view. So I actually have already find view by ID the recycler view and then give the recycler view a layout manager. So what I need to do at this point is to add this node mutable list to the adapter and then assign the adapter to a recycler view. Okay. Now, now this is the whole process of retrieving data and get informations from the API. Do you guys have any questions? Okay. Now we're gonna learn about how to update values inside the nodes. For example, if you're adding something, updating it, it would just be the same thing. And in this case, it will be posting data. So first of all, we need to create a note with whatever new data that we have. Let's just call the username. Let's just call it Android. Android is our user. And the ID, I'm not doing anything with the ID at this moment, but like if you want to, you can actually give it different IDs. Like in this case, all of my nodes ID is just -1. Again, we use request builder to start it off. URL. We have a base URL. So in this case, I'm using this request, so I will be concatenating a /post in the end of our base URL. Oh, post slash, because our URL already have a slash in the end. Okay, what is different between a GET request and a POST request is that a GET request basically just requires you an URL, but the POST request, besides in the URL, you also need an object that's getting passed in, like what you want to post to the API. So after that, we cannot just go just straight for just say build. We need to say like whatever the body we want to post, like the request body. So the the adapter for the Moshi that we just created comes candy again. We're gonna use it to convert the nodes backward to a JSON, because just now we just converted JSON string to a data class, but now we're converting it backward. We're trying to make it a JSON, because this is just a language that backend use to communicate. Too long. Okay. So after converting to a JSON, I'm converting it to a request body, because this is what .post method requires. And then I can say build. The rest of it is very similar. The only difference we have, okay, first of all, we just do like new client new call, and then we input the request post. What? Oh, class is over. Okay, I'm gonna quickly go over. I'm gonna quickly like just do this and then just move on through to actually should I just do it in the, okay, I'll do it next class.
So we'll finish next class, and we'll also introduce the homework next class too.
Okay,
I mean, it's
yeah.
already up, but we'll
It's
do
already
this
up.
informally next class. Or this next discussion Wednesday. Yeah. Thank you guys for coming.
We'll also be going over profiler debug, like networking debugging to a next class. So yeah, really helpful.
Oh yeah, yeah.
start with view pager. Will be also be fine.
Yeah. Okay.